With the Qualification Maths, today I've used Chat GPT to find 10 increasingly difficult differentiation questions for higher maths. I thought I'd have a look at this and see how good Chat GPT and AI is at actually generating questions, and I must say I'm quite impressed. I had to play around with it quite a bit. You can see here I've put in pretty much the course spec, and when I first did it, it gave me a set of questions where it included things like the product rule, the quotient rule for advanced higher maths, which obviously is not included in higher maths. But after playing around for it a bit and swapping out one or two questions, I think I've got a good set of questions which are actually quite nice and they actually work out quite well. So stick around, see how many you can do. We've gone from level 1 all the way to level 10 in differentiation. Can you get all the way with this? This video is sponsored by Lecky, and they are offering viewers of this channel 30% off of any of their books. All you have to do is use the code Claire on Maths, and the link to their books is down below. Now let's look at a couple of their books to highlight. We've got National 5 Maths and Higher Maths, and these are complete revision and practice. 2 books in one. We cover the whole course. Here's a random page, for instance, working simultaneous equations algebraically. You can see how good that book is and how clear it looks. But also at the end, practice exam papers that look exactly like the SQA exam papers that are published. Discount code Claire on Maths. Click the link to order now. So let's see what Chat GPT came up with. Level 1, basic power rule. Differentiate the following function with respect to x. F of x is 4x cubed minus 5x squared plus 2x minus 8. Apply the basic rule for a polynomial power rule. Now this should be okay, I think. So we've got f dash x, and we need to do, well, 3 times 4 is 12. Take the power down, x, and then take away 1 for the power, squared. Take the 2 down, 2 5s is 10, and then take away 1 for the power, so that's just x. And then 2x, well that's got a power of 1, so 1 times 2 is 2, and then x to the power of 0, so there's no x. So it should be 12x squared minus 10x plus 2. No need to factorise it, we just want the final answer there. Okay, let's see what it came up with for question 2. Higher powers of x, it says, differentiate the following function. F of x is a third x to the 6 minus 4x to the 4 plus 7x squared. So similar to question 1, but we've introduced a fraction and I've just made the numbers a little bit bigger. So let's see how this works. So f dash x, still just the power rule. So it's 6 times a third. So I'll just write 6 thirds, I think, x, and then take away 1 to get 5. Minus 4 times 4, so I can do 16x, and then cubed. Take away 1 for the power, plus 7 times 2 is 14, and then it's x to the 1. I need to simplify that answer. 6 divided by 3 is 2, x to the 5, minus 16x cubed, plus 14x. Pretty confident that's the answer. Level 2, done. What it came up with for level 3, trigonometric differentiation, it says, differentiate the following function. F of x is 2 sine x minus 3 cos x. Now, to differentiate using basic trigonometric functions. Well, hopefully start of the exam paper helps you with this. Sine goes to cos, and cos goes to minus sine when you differentiate. So if we just do it bit by bit, 2 sine x must be 2 cos x. And then, it's a little bit tricky actually, we've got minus 3. But then we're going to times by, cos x becomes minus sine x. So it's given us a double minus. Thanks very much, Chat GPT, for that. But we can do that, okay, if we keep our head on. 2 cos x, minus times a minus is a plus, plus 3 sine x. Fairly certain that is the final solution. GPT now gives us level 4, chain rule with a simple composite function. Differentiate the following composite function. F of x is 3x squared minus 5 to the power of 5. So a composite function means you're using the chain rule, which is in higher maths, so that's good. At least that's still there. So f dash x. Now the chain rule is you take the 5 down to the front, you leave the function alone, 3x squared minus 5, that's my inner function, and I take away 1 for the power. But then I need to remember to times by. I'll put a dot for times so it's clear. You need to differentiate what's inside the bracket. So 3x squared becomes 6x and 5 disappears. So that means I can just do 5 times 6 is 30x. 3x squared minus 5 in the bracket to the power of 4. Fairly confident that's the answer. Okay, level 5 on this challenge. Chain rule with a trigonometric function. Differentiate the following function. F of x is sine 4x. Okay, so f dash x. Well, I know that sine goes to cos, so that's cos, and then 4x just stays where it is. But then I need to differentiate the 4x, so it must be 4 cos 4x. Now we're done there. Chat GPT has for level 6, finding tangents. Find the equation of a tangent to the curve f of x is x cubed minus 6x plus 5 at a point where x equals 2. So if to use differentiation to find the gradient at a point and then write the equation of the tangent to the line. So you should know that differentiation is a rate of change and it tells you the gradient of the tangent. So if I differentiate f of x and sub in 2, that will tell me the gradient. Then I'll need a point, so I'll sub 2 into f of x to get the y, and then I'll have a point and the gradient, so use y minus b as mx minus a. That'll be my strategy, but let's see if it works. F dash x, 3x squared, minus 6. So at x equal 2, my gradient must be 3 times 2 squared minus 6. 3 times 4 is 12 minus 6. So 6. My gradient is 6. Now keep a hold of that. So I now need my point. So to get my point, I put 2 into the original function. So at x equals 2, y equals 2 cubed minus 6 times 2 plus 5. 2 cubed is 8. 6 2s is 12 plus 5. So I've got 8 minus 12 is minus 4 plus 5. Let me just write that just to make sure I don't mess this up. Minus 4 plus 5. 5 minus 4 is 1. So I've now got my point. My point is x equals 2, y equals 1. And my gradient is 6. Nice. So we can use a and b. Y minus b is mx minus a. So we've got y minus 1, 6x minus 2. Y minus 1 is 6x minus 12. So y equals 6x minus 12. Add 1 is minus 11. Watch your signs. There's the equation of the tangent to the curve. Let's see what Chat GPT gives us for level 7, chain rule with nested functions. F of x is 2x cubed plus 7 to the power of 4. And we have to differentiate it using the composite function, chain rule. Okay, so I think it's telling us a chain rule here because chain rule usually comes later in the course. We've already done one previous in the video, but let's just do another one anyway. F dash x works quite well. You take 4 down to the front, keep the function as it is, 2x cubed plus 7, take away 1 to get 3. Now you just need to remember to times by, whatever this function is, you need to differentiate it. So 3 times 2 is 6, 6x, take away 1 from cubed to get squared. And now just tidy that up. 4 6's is 24x squares, 2x cubed plus 7 all cubed. I think that's the answer. If you need some help for higher maths, remember differentiation, check the video up above. Level 8, determining increasing and decreasing intervals. For the function f of x is 2x cubed minus 9x squared plus 12x. Determine the intervals where the function is strictly increasing or decreasing. So objective, at least it's given us a hint. Use the first derivative to identify intervals of increasing and decreasing behaviour. So what's it asking us here? Well, basically, if you're finding out when a function is strictly increasing or decreasing, you need to examine the stationary points. And then you need to determine what's happening on either side of those stationary points. So remember, stationary points occur, when f dash x equals 0. So let's just start there. F dash x, 3 2's is 6x squares, 2 9's is 18x, so it's minus 18x, and then 12x becomes 12. So I need to factorise that, so make it equal to 0. Well, 6 is a common factor, so that's nice. X squared, 6 3's is 18, 6 2's is 12. That's quite nice actually, because it means I can double bracket that and get x and x, 2 and 1. And 2 1's is 2, minus 2 minus 1's minus 3. So that means that I've got a stationary point at x equal 1 and a stationary point at x equal 2. So now I need to look at the nature of those stationary points. There's two ways to look at nature. Second derivative test or nature table. I'm going to use the nature table because I think most people at higher maths will. So I've got x along to 1 and along, and then I've got another one along to 2 and along. So let's see, f dash x is what we're looking at, and we're just looking at its shape. So picking a number which is less than 1, let's just pick 0. Picking a number between 1 and 2, let's pick 1.5, and then picking a number after 2, let's pick 3. So subbing into here, you could sub back into here, but it's much easier to do it from the factorised version. If I pick 0, you get -1 times -2, which is positive. So it's positive before 1. If I pick 1.5, 1.5 minus 1 is 0.5, well that's positive, but 1.5 minus 2 is negative. Positive times a negative is a negative, so it's minus in between. And then if I pick the number 3, I'm expecting it to be positive, but let's just check. 3 minus 1 is 2. 3 minus 2 is 1. They're both positive, so positive times a positive is also a positive. So kind of our shape goes like this. That's the max. And down, along, up, that's the min. And the question was, determine the intervals where the function is strictly increasing or decreasing. So we'll just need to answer that question. It is decreasing when, well, the ones that are going down the way. So between 1 and 2 is the only time it's going down the way. Every other time it's either 0 or going up. When 1 is less than x is less than 2. Not a less than or equal to, because at 1 and 2 it's 0. And then it's increasing when, well, when it's less than 1 or when it's bigger than 2. And there's our two answers, increasing and decreasing. Reach level 9. Chat GPT says that sketching a graph using stationary points and end behaviour is a difficult question. I agree, it probably is. Given that the function f of x equals this, find the stationary points, determine their nature, sketch the graph. Also describe the nature as x gets very big or very small. Okay, so to analyse the function using stationary points, nature of turning points and end behaviour. Okay, so when you're sketching a graph, you need to know where it cuts to the x and y axis, but you also need to know where it cuts. You also need to know its turning points. Now, turning points are stationary points, so stationary points occur when f dash x equals 0. So we're going to have to do differentiation as well. So I think I'll start with the differentiation. So I'm going to look at stationary points when f dash x equals 0. So f dash x is 3x squared minus 6x and minus 9. And we're going to say that equals 0. So taking the 3 out as a common factor to get x squared minus 2x and minus 3. So that's 3. Let's hope it factorises. X and x, 3 and 1, minus 3 plus 1 is minus 2. So that means that you've got a stationary point at x equal minus 1 or at x equal 3. So now we need to know the nature of those stationary points. There's two ways to do that. You could use the second derivative test or a nature table. Like I say, I think most people use a nature table at higher maths, so I will do the same. So we're going to go x along to minus 1, and then we've got another one along to 3. Notice I kind of do them separately. It's just in case here that there's some sort of thing that makes this function break down. So I always show it separately just to show that. Right, so let's just put it into the factorised form, because it's much easier to use that than the unfactorised form. So we've got 0 here and 0 here. That's good. Now let's just pick a number less than minus 1. Let's just pick minus 2, take a little note. Minus 2 add 1 is negative. Minus 2 take away 3 is also negative. So I'm fairly confident that a minus times a minus makes a plus. That's positive. Pick a number in between, let's say 0. 0 plus 1 is positive. 0 minus 3 is negative. Times them together gives me a negative answer. So these are both negative. And then after 3, let's just pick maybe 4. 4 plus 1 is 5. So that first bracket's positive. 4 take away 3 is 1. That's also positive. So I'm fairly confident that we've got a positive here. We're going to max. And then a min. quite good with that. So then we need to know the coordinates of those turning points. So at x equal minus 1, y equals, well, we use f of x, so we've got x cubed minus 3x squared minus 9x plus 10, so we're subbing in x cubed minus 3x squared minus 9x plus 10. So we need to keep our head on. Minus 1, minus times a minus is a plus, so that's minus 3 plus 9 plus 10. Minus 4 plus 19 is 15. So minus 115 is a max turning point. Do the same for 3. When x equals 3, y equals 3 cubed. Minus 3 times 3 squared minus 9 times 3 plus 10. 27. 3 3s is 9 times 3 is 27 again. 9 times 3 is 27 again, plus 10. The first two cancel, so it's minus 27 and 10, which is minus 17. And that's a min. So 3 minus 17 is a min turning point. So let's have a look at this graph. We've got y and x. We've got minus 115 is up here somewhere. Minus 1 and 15. And 3 minus 17 is down here. And we know that this is a min and that's a max. So it must go like that, cut the axis somewhere, go there. Suppose we could work out where it cuts the y-axis. It cuts the y-axis at x equal to 0. So y-intercept, when x equals 0, y equals, what's the original equation? 0 cubed minus 3 times 0 squared minus 9 times 0, that's all 0, so we get 10. So it's easy to work that out, so we might as well put 10 on that graph, I think. Graph obviously not drawn to scale. We did get asked one last question. Describe the behaviour of f of x as x goes to infinity and minus infinity. What's it asking here? All it's asking is, let's look at this equation again. F of x was x cubed minus 3x squared minus 9x plus 10, I think. So as x gets to positive infinity, which is very big, if you think about big numbers, this is the way to do it. Just think about a really big number, like a million. If I do a million cubed, it's way, way bigger than a million squared, and it's way, way bigger than a million times 9. So it kind of just, the only bit that matters is this bit x cubed. So since x cubed is the only bit that matters, is a million cubed positive or negative? Well, it's positive and it's very, very big, and it's just going to, and as I get bigger and bigger, x cubed is always going to get bigger and bigger. So as x goes to infinity, f of x also goes to infinity. Now you'll learn, if you ever do later maths, that that's not always true. Things can happen, weird stuff when it gets to infinity. But for now, that's good. And when x goes to minus infinity, f of x goes to, well, again, the only one that's going to really matter is x cubed. Because if you think about it, right, if I go a very negative number, let's even say a 10, minus 10 cubed is like minus 1,000. 10 squared is only 100, and I'll be taking away 100 from 1,000, which is quite insignificant if I do then a million cubed. So this is the only one that matters, and when that gets cubed, I get a negative answer, which means it'll just go to minus infinity. So that's all it's asking for. And to be honest, it doesn't get asked much really at higher maths, but I'm pretty sure it might well be in the course spec. And like I say, once again, I'm not going to find out these points because I think it's beyond the scope of this video. So we're going to leave it like that because the question didn't ask us where it cut the x-axis anyway. Okay, level 10. Let's see what Chat GPT thinks of this one. A farmer wants to fence off a rectangle area of 100 square meters along a straight river. No fence needed along the river. Determine the dimensions that will minimize the amount of fencing required. Oh, it's optimization. Yeah, that's level. I think that's level 10 for most of us, isn't it? Apply differentiation to optimize problem in a real life context. even harder optimization problem. It doesn't even give us a shape. It tells us it's a rectangle. It doesn't know picture. I don't think Chat GPT can do pictures. Maybe it can, but maybe it can't do maths pictures. Let's just sketch this out. We've got a river. There's my river. Really bad, I know. But it's a rectangular area, so we can imagine we've got kind of this shape. But we don't. I'll put a dotted line here because it says we don't need one along the river. And we know that the area of this shape is 100 meters squared. Okay. So we could call the length of it, let's say, x. Let's call it x. You can see that's x and that's y. We know that the area equals x times y, which equals 100. So that's good. So we've got one equation, x times y equals 100. So what else do we know? Well, we need to know the total length of the fencing. So the length of the fencing, the perimeter in other words, is 2y plus x. So I've got y plus x plus y. So we could say that the length of that fencing is 2y plus x. I want to get rid of one of these variables here. So I've got y and x, so I'll make y the subject of xy equal to 100, I think. xy equals 100 means that y equals 100 over x. So that means that the length required is 2 times 100 over x plus x. Tidying that up, our length is 200 over x plus x. And we want to minimize the amount of fencing required. So we want to minimize that length. So we want to find out if, when we differentiate that, where the turning points are and the stationary points. So let's just make that differentiable by saying I've got 200x to the minus 1 plus x. And then if I differentiate L, I'll just call it L dash x, because that's a function of x. Minus 200 x to the minus 2, and then x to the power 1 becomes 1 times x to the power 0, which is just 1, so plus 1. Stationary points are when that's 0, so when L dash x equals 0. So I'm saying that minus 200 x to the minus 2 plus 1 equals 0. That looks harder to solve than it is. If I put that back as a fraction, minus 200 over x squared plus 1 equals 0. I mean, I'll make minus 200 over x squared and say that equals minus 1. But if I times both sides by x squared, I'll get rid of the fraction. So in other words, minus 1 times x squared equals minus 200. So I can say that minus x squared equals minus 200, or x squared equals 200, and therefore x is the square root of 200. Now, square root of 200 isn't a square number, so I'm going to use a calculator for this and assume that we want a number. So square root of 200, let's say 14.1. So x equals 14.1 meters. We now need to just check, is that a max or a min? So, nature table. We've got x, we're going along, 14.1, and we're going along. Now, you cannot pick, because we've divided by x squared, you cannot pick 0. Okay, so don't pick 0, it doesn't work at 0. So let's just pick a number close to that, let's say 10 and 50. L dash x at 10, let's just check. 10 squares 100, so minus 200 divided by 100 minus 2, plus 1 is minus 1, that is negative. So I'm going down the way, 0, I'm going along the way, it looks like it's going to be a min then. Try 15, now you might just get a calculator out for this. Minus 200 divided by 15 squared is minus 0.888. So if I add 1 to that, I'm going to get a negative answer, aren't I? No, a positive answer, sorry, yes. That's what I'm looking for, hopefully. And therefore, x equals 14.1 minimises the length of the fencing. (14.1 meters). Does it ask us for the length? No, the dimensions. Okay, I almost missed. I've got x, which is the length. So the width is y, and y, remember, xy equals 100. So we've got x y equals 100. So y equals 100 over x, 100 over 14.1, 7.09. So just to answer the question completely, length of 14.1 meters and height or breadth of 7.09 meters minimizes the length of fencing. And I agree, Chat GPT, that one was tough. This has been Clear Math. Today we've used Chat GPT to give us 10 increasingly difficult differentiation questions, almost impossible at the end there, but doable for a higher maths pupil. Like and subscribe, take care, stay safe, and goodbye.